Okay, guys, so let's start over chapter 8. Chapter 8 is about web application and web wireless network security attacks. We have three main agenda items, starting with the web application attacks. Web application attacks will discuss mainly three types of web application attacks: cross-site scripting, SQL injection, and directory traversal. The second agenda item is we'll talk about some wireless networks and attacks, some security attacks on wireless network. Third is we'll discuss some countermeasures. Countermeasure mean how we can actually avoid web application attacks and how we can avoid the wireless network attacks. So let's start with the first agenda item. Today we're gonna cover the first agenda item, web application attacks, and in the second part of the video we will discuss the wireless network attacks. So web application security or web application attacks. So please remember one thing: web application attacks or web application security is much more difficult as compared to securing or protecting a network or other servers as well. Reason is that we cannot use typical firewalls and all that stuff in order to make them secure. Because these traditional network security devices, they completely ignore HTTP content, HTTP packet, and the virus could be inside those packet. So web application security, please remember one thing: web application security is more difficult and challenging, more difficult or challenging as compared to securing a network or computer systems. The reason is that the typical or traditional network security devices cannot be used to secure web applications. Web applications, since they ignore HTTP contents and the headers, and wireless the malicious scripts or malicious contents can be integrated within HTTP header, and within the when while server and client is doing the HTTP handshake, it could be actually embedded in those HTTP content as well. And most of the web application security attacks are basically zero-day attack, and zero-day is basically an attack that exploits the previously unknown vulnerability. So any attack which is previously unknown is basically called zero-day attack. So because the security administrators, they got 0 day to protect themselves against that attack. So what we discussed, web application security is extremely challenging, since the typical devices or the security tools, they ignore the HTTP content. Three type of web application attacks that we're going to discuss today. One is called XSS cross-site scripting. Second is SQL injection, structured query language injection attack. And the third is directory traversal. So these are the three main attacks that we today we're going to talk about. So let's start with the first cross-site scripting attack. First of all, cross-site scripting is basically a server-based attack where attackers they inject a malware on server and target their clients, the user of that website. So basically, in cross-site scripting, what is the definition? So definition is attackers, or you can say injecting malware onto server, basically the web application server, to target the visitors, or you can say users of that website. So firstly, attackers, they actually find a server which is vulnerable to cross-site scripting, and then they actually upload their malicious script onto it to target the visitors of that website. Now, what is the requirement? How we can say this particular server is basically vulnerable to cross-site scripting? There are two main requirements. A cross-site scripting attack can be executed if a server accepts users' input without validating it. Secondly, user input in a response. So what's basically the process, like how exactly it executes? So let's say there is a website, for example. Most of the time the blogging websites are more prone to cross-site scripting. Why blogging website? Because here users can, like, let's say this is a blogging website where user can create a thread. Attacker can craft a comment. Okay, so you can actually write down a comment. That particular comment can have a malicious content, underlying malicious content maybe. If anybody clicks that particular comment, then what can happen? It could be triggered, like it could be download on the client computer, can steal the data, stuff like that, whatever the intentions or objectives are. But the thing that you need to know about it, like for example, how we can avoid cross-site scripting. Let's say if you are typing something like how Facebook, Twitter, how they actually, because those are also blogging websites, how they actually avoid it. So basically, whenever you type something, let's say if you want to type something, if you want to say something, hey, you are looking good. Somebody upload a picture and you just post a comment, hey, you are looking good. And there could be a possibility that, it looks like you're looking good, but on the back end, you have typed a malicious script, maybe HTML script. If anybody click here to like your comment or stuff like that, so it might redirect them to a fraudulent website. This is basically what cross-site scripting is. I will show you guys in our lab. So in process, what will happen? Attackers post a comment with underlying malicious script. So it looks like a normal comment, but having some malicious script on it. When users or victims, they click the comment to respond, then there could be two options. Number one, it could actually download and install on victim's browser and can steal web browser history and cookies, and also they can access the hard drive stuff as well. Another possibility is it can redirect the user to a fraudulent website which may be installed by attacker. Fraudulent website. So these are the two main possibilities whenever you cross-site scripting attack can be executed. And if you want to avoid it, we need to actually place a filter in between. There should be a filter in between which can sanitize the input. Let's say if you are typing a comment, you want to upload on the server, so there should be a filter in between. That particular filter should sanitize, like whether it's a plain comment or having a malicious content inside that. Okay, next is the SQL injection attack. In SQL injection structured query language, this is the programming language, or you can say a language that we use to pull the data from database. If you want to add entry or record in the database, we can use a SQL command and stuff like that. Attackers can also take advantage of SQL injection attack, and by using SQL injection attack, they can target the SQL servers, the databases, and inject the malicious command to pull the data from database. So let me give you a basic idea of what is SQL injection attack. So let's say, for example, this is a user and this particular user wants to access this web application, let's say xyz.com. So what user will do, user will type xyz.com, and on that web, for example, if this website is have some protected assets or protected access, so there might be username and the password. So user has to complete this form. User will enter his username. For example, if username is Alice, password is 123, the legitimate one. So user will actually forward this information to authentication server. Authentication server will look for a match, or you can say look for an entry in the database, use a pointer. If a match occurs, which occurs in our case, then user can access the web application. If a match doesn't occur, then user will be denied. So that's a typical process. But just see, authentication server stores the data in the form of tables, like in database. So for example, if user, instead of putting the Alice and Bob, if attacker puts, let's say, in the username, if attacker puts, let's say, for example, 1 equal to 1 or some SQL command to pull the data from database. So there is a possibility, like if they put that, there is no filter in between, they can actually pull the data directly from database. This attack is called SQL injection attack, where attacker, instead of putting username in username form, they enter the SQL commands. And if there is no filter in between, whatever user is typing, if it is directly getting to authentication server, so that's called the SQL injection attack. So in SQL injection attack, firstly, as I mentioned earlier, it targets the SQL servers, databases, by injecting malicious SQL commands. What exactly they do, in fact, in the SQL injection attack, attackers take advantage of forgot password option, where, if you hit forgot password, what happens? They don't ask you, like, I forgot my password. They might ask you enter your username and password, and then attackers enter SQL commands to pull data from database. Like what happens when you hit forgot password option. Once you hit forget password option, it gives you option to enter username or email address. So rather than putting username or the email address, they actually enter the SQL commands. Now let's discuss what's the process. What are the different steps involved in the SQL injection attack? So first thing is, attacker need to find whether the website is vulnerable to SQL injection or not. How they verify? So attacker clicks forgot password option, and then deliberately what they do is they actually enter incorrect format of username or email address. For example, whatever is asked, username or email. For example, in the case of GGC, or in the case of, for example, Gmail. So for example, in the case of Gmail, let's say the original format of username could be, let's say, alice@gmail.com. So rather than putting alice@gmail.com, what they can put is, they can do, let's say, something like Alice #? Equal to 10, something like that. So instead of putting this format, which the server might be expecting, they actually put this incorrect format. Now what will happen if the reply comes? If reply comes, let's say, incorrect username format, then it means there is a filter in place. What does it mean? It means, let's say, if you see down here again, let's say if you enter, let's say, other than Alice For example, if you put, for example, hashtag, question mark, something like that. So if it is directly getting through it, so you might expect a response, let's say user not found, error, or something like that. But for example, if they are, whatever you're typing is directly going to database, it means there is no filter in between. They're not sanitizing your input. Then what can happen? It means that website is vulnerable to SQL injection. So if they say incorrect username and format, it means they are properly assessing your format. Then no SQL injection attack. But if respond comes, error, user not found, it means SQL injection is possible. And if the SQL injection attack is possible, then of course the second step is going to be attacker then uses SQL commands to get column or row of the table, just to see all the username and password. This is called SQL injection attack. In our lab 8, we will practice that by using SQL map software. Next is the directory traversal attack. If you see, typically the computers are organized in directories. So whenever you, let's say, visit a website, typically what happens? Typically you are restricted to only the World Wide Web Services, that particular directory, where the website could be located, HTML pages or some application and stuff like that. So in directory traversal attack, what happens? So basically, being a user, you are restricted to website and the, let's say, other pages. But if you try to actually go out from these directories and try to access some other directories which you're not supposed to access, this is called directory traversal attack. So if attacker uses professional tools to access those directories of web server which they are not authorized to, then it is called directory traversal attack. And the most widely used tool is for directory traversal is the .pwn, which uses Perl programming language, in fact. So that's the most widely used tool, which still try to you can say exploit the vulnerabilities of the web servers. Next is the last item for today is poisoning. Poisoning is it's basically introduction of a substance, a poisonous substance, in fact, to harm, or you can say destroy, normal operations of a system. So this is basically called poisoning. Now there are two types of poisoning. One is called ARP poisoning, address resolution protocol poisoning, and second type of the poisoning is called DNS poisoning, domain name system poisoning. So as you guys are already familiar with ARP protocol, address resolution protocol, which resolve MAC IP addresses into MAC address. As you know, for local area network communication, devices need to know the MAC addresses of each other. So all the devices in the local area network, if they want to communicate with other devices, they need to know the MAC address of that device. So let me explain you what is basically ARP protocol. And once we discuss the ARP protocol, then we will discuss the ARP poisoning. What is ARP poisoning and what could be the problems with ARP poisoning. So in ARP protocol, let's say, for example, I have two computers connected by using, let's say these are connected by using Ethernet. So let's say I have two computers in a network, computer A, computer B, which are connected with Ethernet. Now computer A wants to send a packet to computer B, okay, by using, let's say I just want to send a ping packet. to computer B. Since both of these devices are connected over the same network, local area network, so they need to know the MAC address of each other. So this is how the Ethernet packet looks like. I will have IP packet which might have some ping, some data. Then I know the source address, which is AAA. Source is this is source address of the computer, but I need to know the destination MAC address as well. And for example, this computer B is just connected with local area network. So I know the IP address, and switch told me the IP address. I know the IP address, but I don't know the MAC address of that device. Now what will happen? This computer will send a ARP request. ARP request is basically like something like that. Hey, my name is this, this is my IP address. This is my source address, MAC address, sorry. I'm looking for 2.2.2. I'm looking for the MAC address of this particular computer. So everybody, this is called ARP request. ARP request is a broadcast signal. Everybody will receive it, including the computer B. So once computer B will receive it, it will update its ARP cache. Like it will update the ARP cache. ARP cache is basically where we actually store the MAC addresses next to their IP address. It will store, okay, 1.1, this is the MAC address of 1.1. It will respond back to computer A. Some other computers, if they might be in the network, they might respond back to computer A as well. Let him know, hey, this is my IP address and my MAC address is B.B.B. So computer A will add it into its ARP cache, the local ARP cache, and you can type here 2.2.2.2 B.BBB. And then this MAC address will be added in the packet, and this packet will be delivered to B. Overall, this particular process is called ARP protocol, where devices, they update their ARP cache because they need to know the MAC address of each nearby devices. Okay. Now, what is ARP poisoning in that case? So let's say this is, for example, computer Bob. For example, this is Alice. So Bob and Alice, this is the IP address of Bob. This is IP address of Alice. Oh, sorry, Bob, MAC address of Bob. This is Alice IP address, Alice MAC address. So we have attacker also, we have attacker in the network. Attacker, this is attacker's IP address, and that's attacker's MAC address. So now let's see what's gonna happen. So Bob wants to send a message to Alice, but before Bob does that, attacker just reach out to Bob and let him know, hey Bob, do you know Alice, her MAC address, the previous Alice which you knew, she's gone. The new Alice, this is her MAC address, CCC. Attacker is giving basically his MAC address to Bob. Try to trick him. Once Bob will receive that, Bob will add it. Okay, so 2.2.2 was MAC address is CCC. Now Bob will say thank you to attacker. Thank you. Attacker will do the same thing with Alice. Reach out to Alice, let her know, hey, do you know Bob, the new Bob's MAC address? Here it is. So CCC is the MAC address of Bob. So Alice, she will also say thank you for keep updating. Now what happens? Let's say now Bob wants to send a packet to Alice. So this is the packet. Bob wants to send this packet to Alice. Now what will happen? Bob will send the packet to CCC. Now this, who will receive it? Attacker, not Alice. And attacker can modify this and send it to Alice or whatever attacker wants to do. Same is the case with Alice. If Alice wants to send a packet to Bob, so who will receive it? It's attacker. This particular attack is called ARP poisoning attack, where attacker modifies the MAC addresses or ARP cache of all the nearby users. So what could be, you can say, problems, or what are basically the possibilities? Attacker, by executing ARP poisoning, attacker can steal the data. Let's say Bob wants to send something to Alice. Who's getting his attacker? Prevent internet access and DOS attack, or you can say man in the middle. MIMA, man in the middle, like attacker. Bob wants to send something to Alice. Firstly, attacker will get that. Attacker can tamper the data and send to Alice. This is called ARP poisoning attack. There is a tool in our lab. I will show you guys in our online session. The tool is called Ettercap. Ettercap is basically the tool that most widely people, they actually use that tool for the ARP poisoning attack. The last thing for today is called DNS poisoning attack. DNS poisoning. So DNS stands for domain name system, and domain name system basically resolves DNS domain names like www dot whatever it is to IP addresses. As you know, computers, I mean over internet, IP address is basically the name of the device. Like if you want to access google.com, you cannot directly access google.com without knowing their IP address, and it is very hard for the humans to memorize the IP addresses. So that's why we use DNS, domain names. Computers, they do have a local copy of domain names of the website which you frequently access, or sometime it happens if you want to access, let's say, just see the scenario. Let's say if you want to access google.com, so you will open your browser, type google.com. This information will get to your ISP with an DNS server. There will be DNS server as well. DNS server has a table where we have IP addresses with their DNS. So this google.com, they will find the google.com, convert it into IP address, and then redirect you to google.com. In DNS poisoning, the attacker, what attacker has to do? Attacker has to modify this particular IP address in the legitimate DNS server. Attacker will actually deploy his own DNS server, where attacker will actually try to convince the legitimate DNS server that google.com is now located on 2.2, which is attacker's website in fact. So now what will happen? Let's say if attacker successfully can do it, what will happen? So attacker can actually modify 2.2 with 2.2. Now if user is typing google.com but DNS server is redirecting you to attacker's website, this is called DNS poisoning attack, which is not that easy of course, but it is what it is in fact. So definition of DNS poisoning is DNS poisoning substitute DNS address to redirect a computer to a fraudulent attacker's website in fact. So fraudulent website. So this is called DNS poisoning. So we will discuss the issues in our online session.